Over the past month, the scientific community responded to one of the most pressing climate concerns with the release of the Global Methane Budget 2025. Methane concentrations have now surpassed 12 parts per billion, marking the highest atmospheric value in at least 800,000 years. This surge, driven largely by agriculture, fossil fuel extraction, and microbial emissions from wetlands, confirms the acceleration of a greenhouse gas that is more than 84 times as potent as carbon dioxide over a 20-year horizon. The new budget highlights that wetland methane emissions have increased by 7% from 2000 to 2020. Scientists at NASA's Jet Propulsion Laboratory explain that warmer temperatures have expanded microbial activity in peatlands. This month's synthesis reflects a massive scientific effort drawing on satellite platforms like Tropomai, ground-based flux towers, and inverse modeling systems. Together, they reveal that natural and anthropogenic methane sources are now rising at rates that challenge global mitigation pathways outlined under IPCC AR6. What is especially striking in this month's analysis is the identification of methane superemitters, clusters of oil and gas facilities responsible for disproportionately large leaks. The International Energy Agency noted in its November commentary that eliminating these preventable leaks could cut methane emissions from the fossil fuel sector by 75% at a net cost close to zero. Countries including the United States, Turkmenistan, and Algeria were flagged as high-impact zones where rapid regulatory reform could deliver some of the most cost-effective climate benefits available today. If managed proactively, methane reduction could avoid up to 0.3 degrees C of global warming by 2045, according to UNEP's Global Methane Assessment. This becomes particularly important when we consider the latest seasonal climate data published last month by the World Meteorological Organization. A rapid methane decline, therefore, acts as an atmospheric cooling lever, offering one of the few tools that can produce measurable temperature benefits within a decade. A reduction of 1 million tons of methane leakage each year translates into roughly 26 million tons of CO2 equivalent reduction. It also reduces tropospheric ozone formation, which the Lancet Commission on Pollution and Health associates with nearly 700,000 premature deaths annually worldwide. In agricultural economies such as India, China, and Brazil, the reduction of ozone could protect crop productivity and potentially avert annual losses valued at billions of dollars. At the same time, the methane budget underscores an unavoidable truth. Natural feedback loops are strengthening. The newly published wetland observations reveal that climate-driven methane emissions are expanding even in regions with minimal human influence. This means that mitigation efforts must now outpace natural system amplification to keep temperature limits within reach. Scientists at ETH Zurich emphasize that failure to reduce anthropogenic methane by at least 45% by 2030 would make Paris Agreement ambitions extremely difficult to achieve. In summary, the scientific documents released this month deepen our understanding of methane's accelerating role in global warming and provide governments with a clear roadmap. The message is direct and urgent. Methane offers the world a rare opportunity for high-impact, fast-acting climate mitigation. Acting on this evidence can slow near-term warming, safeguard food systems, improve air quality, and reduce premature deaths. The next decade will determine whether methane becomes a symbol of climate failure or climate leadership.